In order for us to be able to solve word problems, we first have to be sure that we understand our exponential equations. So that's what this video is going to be for. And then tomorrow in class, we're going to solve word problems together. This is our basic equation for exponential. So we know that this is going to be an exponential graph because the variable is in the exponent. All graphs, like we have modeled before, had their own equation, and it's the same for exponential. So just a quick review, that was our linear equation. And you also know all about your quadratic equation. And then you learned sinusoidal equations. And so this one here is exponential. Now just from its multiplication in between, so we have a times b to the power of x. When we're talking about things, let's look, for example, we might be looking at money that has been invested that is growing over time. Money invested growing over time. That'll just sort of help us a bit here. When you hear of something that's growing exponentially, it means that it's growing really quickly. And you know from your graphs the other day that you saw that. So first of all, the a in the equation is our initial amount. So if we were to deposit $500 at the beginning, our a is equal to 500. Our b is our growth or decay rate, whether our money is increasing or decreasing, whether we're losing money. Our y is our final amount. So after 5 years, how much money is actually there. This equation works for bacteria, population, all kinds of different things that grow exponentially. Our x is our time periods. So x is not always in years. It depends on the time that we're talking about. So we're just going to look at now our growth decay rate a little bit closer. If something is doubling, so if you put money into a bank account and it doubled every month, then b would be equal to 2. You could just quickly substitute into the equation b equal to 2. If something is tripling, then b would be equal to 3. Now, as in cars, or sometimes investments, if you were losing half of your amount, so if there was a half-life to something, you lost half of it every month. You started with $1,000, and next month you only had 500, then b would be equal to 1/2. So those are fairly easy values to remember to substitute into b. What we have to just sort of keep in mind is sometimes b is going to come in the form of a percent. So if something is growing at a rate of 2%, we need to first change that to a decimal and add it to 1. So b will be 1 plus decimal 0.02. If something is decay, if we're losing it, then we need to take that percent and subtract it from 1. So these are our b values that we substitute in our word problems. So let's just roughly go over this. Make some space here. So if we have a population of 1,000 people, and we know that it is growing at a rate of 1.3% every year, we can write an equation for that. So let's remember that our exponential equation looks like this: a times b to the power of x. So y is when we're looking for our final amount. We started with 1,000 people, and we are growing at a rate of 1.3%. So we first change that to a decimal, the 1.3%. To change it to a decimal, remember that you divide by 1,000. Sorry, divide by 100. I have one too many zeros there. which is equal to 0.013, and then we add it to 1. So now we have an equation that no matter how many years we're looking for, we can look for the population in 5 years and 10 years using this. So if I wanted to know how many people there were in 5 years, we could just substitute 5 into the equation. Or if we were looking at it for 10 years, we could just substitute 10 into the equation, etc. So what this does is this shows us what A, B, and X are. Now bringing this knowledge into class tomorrow, we can apply it to our word problems.